So recently you guys learned about perfect square roots. Unfortunately, there is really no way to get an exact answer for a non-perfect square root because non-perfect square roots all have decimals that do not terminate, meaning they are infinite numbers that go on and on and on. When you use your calculators to solve them, obviously your calculators will have a stopping point, and because the screens are only so large, but that does not mean the decimal actually stops. So when we talk about non-perfect square roots, we don't talk about solving non-perfect square roots. We simply talk about estimating non-perfect square roots. So any square root that you do not get by multiplying a number by itself. So we know that there is no number that we can multiply by itself to get 8. So the square root of 8 is considered a non-perfect square root. There is nothing that you can multiply to get 32 by itself. So the square root of 32 is a non-perfect square root. And of course, these go on and on and on. You'll actually have more non-perfect square roots than you will perfect square roots because there's a lot more numbers that we could do. So we could do 12, we could do 13, we could do 42. These are all numbers that you cannot multiply an integer by itself to get. So not 6 times 6 or 7 times 7 or 8 times 8. So these all are non-perfect square roots. So go ahead and take a minute before we get to the notes. And I need you guys to go ahead and write the title of the notes at the top of your page. Write estimating non-perfect square roots. We actually don't have a lot of notes for this. We only have one example really that we're going to look at together, and then we're going to do a bunch of problems together. But I do recommend that you have a good example written down in details explaining how to do it in your notes. After you copy this title, you can go ahead and add some examples of non-perfect square roots underneath of it like we did around the title in your notes. And then put your pencils down, and that'll let the sub know that we can continue, and she will press play on the video. So the first example that we're going to look at is estimating by finding two consecutive integers. This is kind of a word that we're probably not used to hearing. Consecutive integers or consecutive numbers are numbers that come one right after the other. So 1 and 2, or 8 and 9, or 11 and 12. These are all consecutive integers. They're numbers that come one and then the next one right after the other. So we are looking for two consecutive integers that the square root of 30 falls between. So the easiest way, or one way to do this, is to look at your list of perfect square roots that you made in your notes a couple of days ago when we talked about perfect square roots. And you're looking for what two square roots does 30 fall between. So if you're looking at your list, you should have 4 times 4 square root of 16, 5 times 5 square root of 25. And then this is not correct. And then that's strange. I don't know why that arrow is there. It's off a little bit. And then the square root of 36. So 30 is greater than 25 and less than 36. So it would fall between these two perfect square roots. But it's not asking the square roots it falls between. It's asking for the consecutive integers it falls between. So then you would need to solve those square roots that are the perfect square roots. So the square root of 25 is 5 and the square root of 36 is 6. So the square root of 30 is going to be between 5 and 6, and it's going to be a decimal that falls between the whole numbers or the consecutive integers 5 and 6. And so you can actually use a calculator to get a specific answer, and let me show you that. So you can go ahead and type into your calculators. Your calculators are going to look a little bit differently than mine, but you always type in the number inside the radical sign first. So you do 30. And those of you who have your phones, you're going to have this button on your phone that looks like a radical with a 2 outside. That's for square roots. You'll learn about cubed roots, not this year. possibly in Algebra 1. I'm really not sure what grade you learned that in, but this radical sign with the 3 is for cubed roots, not square roots. So you would type in the 30 and then you would do the square root button. If you don't have a scientific calculator and you just have one of the basic function calculators, it just looks like a regular square root sign. There's not a little 2 on the outside. So specifically, this is, again, it goes past the 6 here at the end of the screen. That's just all that can fit on there because it does not terminate. It does not stop, even though the screen runs out. And so this shows that it's approximately, if I were to round this to the hundredths place, it's 5 and 48 hundredths. If I were to round this to the tenths place, it's 5 and 5 tenths. So in math, when we approximate an answer or a solution and it's not an exact answer, we use a sign that does not look like an equal sign. It looks like this. That's kind of the best I can do, but it looks like a squiggly or a wavy equal sign. And that means it's an approximation or an estimate. And in this case, I'm going to go ahead and round it to the hundredths place, which was 5 and 48 hundredths. And what place do you want us to round it to, Ms. Dunn? That's always the question I get. My answer is whatever the directions tell you to do. So you're going to round it to whichever place value spot the directions tell you to round it to. So this is the exact number or decimal. It's really not exact, but it's a little bit more exact than just between the whole numbers 5 and 6. And these are the 2 consecutive integers that it falls between. Now, last year I saw a student do it, and I don't know why I never thought about doing it this way, but I just thought it was fantastic. They started with the approximation, and they typed it into their calculator, and then they looked at the whole number place, and they knew that this decimal fell between the whole numbers 5 and 6. And so they worked from the answer on their calculator backwards to finding the 2 numbers that it fell between instead of using their list of perfect square roots. And I just thought that was a really easy, simple way to look at it also for estimating or approximating the 2 whole numbers that it's between. If that makes sense to you, that's another really great strategy to use, and I say go for it. Okay, so before we begin our practice looking at some problems of doing this, I would like for you to pause the video and copy this example into your notes. So let's practice doing some of these. So the first one that you guys are going to do is I want you just to name the 2 consecutive integers the square root falls between. And so the first one is the square root of 6. It is a non-perfect square root. And I just want you to name the 2 integers. I don't want an estimate. I don't want it rounded. I just want the 2 integers that it falls between. Go ahead and pause the video and try number 1 on your desks with your expo markers. Okay, so if I'm looking at my square root list, I know that 2 times 2 is 4, and 3 times 3 is 9. So the square root of 6 falls between 4 and 9, which is between 2 and 3. So your answer to number 1 should be between 2 and 3. All right, pause the video and try number 2. So if I am looking at number 2, again, I'm going to be looking at my list, and I'm just going to go down one by one. Obviously, I don't have the list here, but I can picture the list in my head because I know my perfect square roots. I know 4 times 4 is 16. I know 5 times 5 is 25. And I know that the square root of 20 is between 16 and 25. So this falls between 4 and 5. All right, let's try one more. Go ahead and pause the video and try and find what 2 consecutive integers the square root of 44 falls between. All right, guys, so looking at my list, I know that the square root of 36 is less than 44, and the square root of 49 is more than 44, and 44 falls perfectly between 36 and 49. So the square root of 36 is 6, and the square root of 49 is 7. And so the square root of 44 falls between 6 and 7. Hopefully you guys think this is pretty easy. This is one of the easiest things I think we get to do this year. So now just another direction that they often make us do is approximating. And really the only issue that we should have with this is if we are struggling with rounding. And I'm going to be really honest with you guys, I'm not going to help you with rounding. You guys should know how to round in pre-algebra, but I will just give you a quick little reminder of decimal place value spots. So this is, if this is my decimal, this is my tenths, this is my hundredths, this is my thousandths. So if they're wanting us to round to the hundredths, we are going to look at the digit in the thousandths place. If it is between 1 and 4, the digit in the hundredths place stays the same. If it is between 5 and 9, the digit in the thousandths place, if it's between 5 and 9, it makes the digit in the hundredths place go up to the next digit. So hopefully we all know that, and I just insulted your intelligence by having to explain to you rounding. But year after year after year, as I teach this lesson, my students get them wrong because they round to the tenths place instead of the hundredths place, and then they get frustrated and upset. And guys, I will mark it wrong if you round it to the wrong place value spot. I'm not going to say, oh, they know how to do this. No, rounding is part of the directions. If you are rounding it to the wrong spot, you're going to get it wrong. So make sure you know those decimal place value spots and make sure you're rounding to the correct spot. So go ahead and pause the video, and I want you to solve for the square root of 63 and round it to the nearest hundredths place. Yes, you can use your calculator. I do not expect you to find this any other way. All right, guys, so just remember when you are doing square roots on your calculator, you're going to type in 63 first, then press the square root button. So I'm going to write down all of the digits through the thousands place, 7.937, 7 and 937 thousandths. And then what I'm going to do is I'm going to underline the digit in the hundredths place, and I'm going to draw an arrow to the digit in the thousandths place. And the digit in the thousandths place helps me to decide what to do with the digit in the hundredths place. The digit in the thousandths place is between 5 and 9. So the digit in the hundredths place goes up 1 to 4. All the digits in front of it stay the same. And all of the digits after it are gone. A lot of times my students put zeros at the end to fill in those spots, but really that 0 is not a necessary digit, and I would never mark it wrong. And I'll also tell you, your multiple choice tests will never have it there. So if you put the 0 there, I hope you also recognize that it's equivalent decimal without the 0 as well. Okay, so let's pause the video and try number 5. If we have 18 and we square root it, we get 4 and 242 thousandths, so on, and so forth. I'm just going to write down these first 4 digits for the purpose of rounding to the nearest hundredths place. So we're just going to write down 4 and 242 thousandths. Okay, so again, I'm rounding to the hundredths place, and I'm going to look at the thousandths place. The thousandths place is between 1 and 4, which means the digit in my hundredths stays the same. Everything to the left also stays the same. And everything to the right is gone or turns into a 0, which you don't need because it is an equivalent decimal. Again, I'm hoping that this is extremely simple for us. So go ahead, let's try number 6 on your calculators. Let's pause the video and try number 6. All right, guys, so on number 6, we're going to start with 87, and we're going to square root it. This is 9 and 327 thousandths. 9 and 327 thousandths. I'm going to underline the digit in the hundredths place, and I'm going to look at the digit in the thousandths place. The digit in the thousandths place is between 5 and 9, which means the digit in the hundredths place goes up to 3. All the digits in front of it stay the same and all the digits after it are gone, or you can add a 0. So my answer is 9 and 33/100ths. Again, I hope you guys think that non-perfect square roots are very, very simple. It's one of the easiest things that we get to discuss this year. Make sure that you have all of this in your notes. If you need to go back and look at any of it, it is available. The video will be available on Canvas, as well as the notes that were used in this video.